Hello, my name is Hakkı Emrah Erdoğan from UNCCD Data Team, and today I'm going to present you the sub-indicator on land productivity. My presentation will be in 5 headings. The first, I'm going to present you the concept and main drivers of land productivity. In the second part, I will introduce you the UNCCD Default data for reporting, and I'm going to present you how you can interpret this default data. And in the fourth part, I will give you the brief information for the methodology for assessing land productivity and associated good practices, and then we will have the conclusion. Land productivity is the biological productive capacity of the land. It points to long-term change in the health of the land and reflects the net effects of change in ecosystem functioning on plant and biomass growth. So it can be measured across large areas from Earth observation. It can also be measured at global to local scales using satellite remote sensing and image transformation that are sensitive to change in plant productivity and are correlated with the annual land production of vegetation. Specifically for the UNCCD reporting on SDG indicator 15.3.1, it is not necessary to quantify the magnitude of change in productivity in biomass units of annual net primary product as kilogram per hectare per year, but only to know whether productivity is increasing, positive change, or decreasing, negative change, or stable for the land unit at the particular time. And land productivity main drivers in general follows the climatic gradients, and rainfall is a major constraining factor in most of the areas. It varies not only in space but also in time. This variability in land productivity occurs at different time scales from seasonal to interannual in response to the variability in rainfall. The climate is not the only variable. Also, soil topography and management have a role in modulating land productivity at final scale. It is strongly associated with land use and land cover to some extent. For example, the class bare soil has consistently very low land productivity, whereas the class forest typically has high land productivity. It's also cut across land use, land cover classes and captures within class variability. Particularly in land cover class savanna, land productivity varies widely from place to place. And now in the following slides, I'm going to present you and introduce you the UNCCD default data on land productivity. Shortly named LPD, Land Productivity Dynamic Default Data, which was delivered to the country parties for LDN TSP, is also used for reporting. This dataset developed global standards provided by the European Commission Joint Research Center. And in this table you can find the information about data specification. And very briefly, this dataset has 1 kilometer spatial resolution, and it covers the observation of 10 days interval from 1999 to 2013. And the dataset aggregated like 6 classes. First, declining productivity. The second one, moderate decline. The third class is stressed. 4 classes stable. 5 classes increasing. And the 6 classes, no data, which cover the place where there is no information about land productivity. While assessing the data set in PRAIS portal into the country zip file, the following elements of the data sets are provided to the country parties. The one is layout maps in PDF and TIFF formats. One is the raster data in two projection system. One is modest sinusoidal and the another one the VGC 84 decimal degree. And the another element you will have is the metadata. And finally, all the countries will have the reporting table for LPD for each land cover classes and for the next net area change for each land cover change. Addition to that, the UNCCD Secretariat provided high-resolution land productivity data respecting to the requirements from small island developing countries. This data also delivered to the 36 countries. The data provided by using modest sensor 250 meter spatial resolution. It is daily and weekly intervals from 2001 to 2015. In this slide, you can see the example of products that you can find in the country zip file on the PRAIS 3 system. The one is the map of land productivity dynamics. It's a TIFF file or the PDF format layout. And the second part is the reporting table in an Excel format. And you will have two tables associated with land use, land cover classes, and also associated with the land conversion and the land cover change. Following slides present useful information to clarify and strengthen the understanding about interpretation of LPD dataset. For the interpretation in the country's zip file, you can check in this table in the reporting manual. This table gives you explanation of each LPD classes associated with land degradation. For instance, declining and moderate decline indicate a high probability of recent active land degradation process. When you see the land productivity dynamic classes as stressed, it's often represent persistent strong interannual variation in land productivity, which indicate the beginning of instability in land conditions. When you see this stable, it indicates a low probability of active land degradation and therefore a satisfactory or acceptable situation. But it doesn't exclude the possibility that the land has already undergone degradation process and has reached a new equilibrium. It is, for instance, it is not a further degrading but also not recovering. When you see the increasing, it indicates a satisfactory or improving situation from a degraded state, but in some cases it may also indicate unfavorable process such as shrub encroachment in grassland or land abandonment. In this figure, you can see the distribution of land productivity dynamic classes in Madagascar. It's referring to observation period from 1999 to 2013. And approximately 32% of territories vegetated land surface show persistent declining trend or stress on land productivity. However, approximately 54% of the territory is stable, and approximately 10% of total area show increasing in land productivity trend as represented in the figure. It is a country overview. When you go into the details in the reporting tables, for example, in the tree covered area, approximately 50% of tree covered areas show stable productivity trends, while approximately 13% shows an increasing in land productivity trends. However, approximately 33% shows a persistent declining trend together with class 1 and 2 or the instability class 3. Let's do another example on the croplands in Madagascar. For example, approximately the 46% of croplands show stable productivity trends, while approximately 25% show an increase in land productivity. Again, approximately 22% of croplands show persistent declining trends. When you will look to the second table, which is associated with the land conversions, in Madagascar example, like during 2015, 5,024 km square area converted from tree covered areas to croplands. And when we look into the detail in this conversion, approximately 20% of these converted areas show an increase in land productivity trends. And again, approximately 25% of croplands show a persistent declining trend. This approach allows to monitor the impact of land cover transformation to the ecosystem function. For example, the deforestation is always thinking like a main driver of the land degradation, but in these examples show that transformation from tree covered areas to the croplands can improve the land condition, as what happened in here, like 5,057 km square areas improve in Madagascar. In the end, on the interpretation of LPD, land productivity default data, we have to know that declining land productivity is not equivalent to land degradation. For example, land-intensive agriculture may decrease yields in the short term, but improve environmental quality in long term. Also, we have to know that the increasing land productivity, it's not mean that land improvement. For example, intensive agriculture may increase yields in the short term, but reduce environmental quality in the long term. And the third one that we have to know that land degradation means it's declining land productivity. So degraded land will always perform worse than its unaffected counterparts. So these are the key elements that we have to keep in our minds when we are doing interpretation on the land productivity data. And for the further information about the default data set and the interpretation, you can use these reference documents like in Good Practices Guidelines published in 2017 and Global Land Outlook, and also the reports, technical reports provided by European Commission on land productivity dynamics and assessment at global scales. And now, in the following slide, I'm going to present you the methodology for assessing land productivity. If the counterparties would like to use the alternative data sources for assessing land productivity, they should follow the UNCCD Good Practice Guidance. In this guidance, you can find a roadmap and recommendations for processing steps that should be followed. As you can see in this table, in the guidance, I recommended to use the three metrics from remote to sensed estimates like trend, state, and performance. You can see the possible processing steps, that how you can provide this data in using the national information or the alternative global data products. In the conclusion, specifically for the verification and the validation of the land productivity data, we should consider that land degradation is a very complex phenomenon, and we don't have agreed field measurement protocols today. Specifically for the land productivity dynamics, we have to consider that this is a proxy for land degradation, not a measure of land degradation. And we also have to consider that is the complex social, economic, and biophysical process are drive both positive and negative change in land degradation dynamics. So that's why there is a need for systematic validation, including further analysis of the causes, statistics, and economics behind the observed change.